MEM School of Engineering, Department of Electrical and Electronics Engineering, online classes, subject Digital Logic Circuit, Unit 3. Myself, Saravanan, Assistant Professor, Mechatronics. This is the core subjective of Digital Logic Circuit. This is the syllabus, textbooks and reference. Then Unit number 3. Synchronous sequential circuit. So sequential circuits, already we know that output depend on the present input as well as the past output called synchronous sequential circuits. So synchronous sequential circuit having two types. One is synchronous sequential circuit, another one is asynchronous sequential circuit. Okay, so that is okay. So synchronous sequential circuit means the whole circuit was controlled by the common clock pulse. So there is only one clock pulse available in this model. So it will communicate. It will enable and disable the whole flip flops with the single flip flops. So that is synchronous sequential circuit. It is having a flip flops. Uh, that is a flip flop is a memory element that was used in the sequential circuits, as well as registers, counters like that we are used in the synchronous sequential circuits. Let's see one by one. First is sequential logic. Okay, when we go for uh, load the, that is save the previous outputs, we need a memory element. So that is the called flip flops. It is a one bit storage. It is a one bit storage element which is it is a one bit storage element which is controlled by the clock pulse. That is sequential logic circuit. That is SR flip flop, JK flip flop, D and T flip flop. So that is output depend on the present input as well as the past output. So synchronous sequential means where discrete instant of time and time determine the behavior. So asynchronous sequential circuit where the behavior depends upon input signal occurring at any instant of time. So behavior is also determined from which input signal change. So that is sequential circuit. Sequential circuit having two types. One is latch, another one is flip flop. So storage elements that operate with the signal levels means that is called latch. Storage elements controlled by a clock transition or flip flops. So first flip flop is SR flip flop. That is S means set, R means reset. Okay, this is a basic flip flop used in the flip flop operations. That is the first one is a truth table of flip flop. That is S and R, that output. If both the inputs are 0 means there is no change in the previous state. If previous state 0 means next state will be 0. If previous state 1 means next state will be 1. That is the concept. When 0 and 1 means output will be 0 because here we are enabling the reset. So output will be 0. So when 1 and 0, so here 1 and 0, that means we are enabling the set. So output will be 1. If we are giving 1 1 means it is a forbidden condition. That is there is no process. So it is a don't care condition for this truth table. So this is the characteristics table for the SR flip flop. That is, if your previous state is 0, what will happen? If previous state is 1, what will happen, like that we are defined. Okay, from that table we are defined the characteristics equation. So Q of n plus 1 is equal to S plus Q dash and R dash. Okay, from that we are defining the state. So the state here we have only two states, 0 or 1. So when Q is equal to 0, that means when S is equal to 0, R is equal to 0. So this will be remain in the same state. Okay, same as here. It will be 1 means it will same in the state. If it is change, if S is equal to 1 means this state will change to the 1. If R is equal to 1 means this state will be changed to 0. So this is the concept of SR flip flop. Then second one is JK flip flop. So this is also same 90% same with the SR flip flop. Here J is a set, K is a reset. Same 0 0 means no change. So 0 1 means it is a reset, so output will be 0. So 1 0 means it is a set, so output will be 1. So here this is the change in the previous SR flip flop, that is the 1 1. Here 1 1 is complement. Okay, what the input is, so that value complemented in the output. So this is the characteristics table. Second one, for the input of 0, what is the output? For input of 1, so what is the output, like that it is defined. Then we are derived the using K-map, we are derived the characteristics equation. Then state diagram. Here when 0 0 means same state available. So here also 0 0 means same state 1. When j is equal to k is equal to 1, it will be complemented. Same condition, j is equal to 1 is equal to k is equal to 1 means the state will be changed. As well as j value will be 1, k value will be 0 means it will be set. Here j value is 0, k value 1 means the q1 will be reset. So only they are putting this way, they are putting the arrow mark. This is the jk flip flop. So next one, D flip flop, it is called a delay flip flop. It is used as the buffer. So what we are giving the input, so output will be there. So 0 and output 0 and 1 and output will be 1. So why we need the 0 2 or 0 1 1 2? We can directly connect the wire. Why we are using the D flip flop? So that means delay. Okay, if you give clock pulse, one clock pulse, then only the 0 will be connected with the output. So you have required time for execution, this process will be one clock pulse. Okay, this is the delay, that one clock pulse. If you want to use a 5 clock pulse spin, you have to use 5 D flip flop in the series manner. You can get the 5 clock pulses delay. This is mostly used in the buffer circuit. Okay. So here D is equal to 0, output is 1. So here there is no previous state verification. If D is equal to 0, next state will be 0. If D is equal to 1, next state will be 1. So only here next state will be defined as the with the D. So it is not dependent on the Q. So next one, T flip flop. So T flip flop is a toggle flip flop, that is opposite of delay. So that means if it is t is equal to 0 means no change, if t is equal to 1 means complement, that's all. If t is equal to 0 means there is no change, if it is 0 means 0, 1 means 1. If t is equal to 1, complement will be there, that is 0 means 1, 1 to 0. So that is represented as q of n plus 1 is equal to q xr of t. Okay. So these are the four flip-flops used in the design of synchronous sequential circuits. Okay. So using these four, we can implement more number of applications like registers, shift register, counters, like that we can implement using the this flip-flop. Okay. So next chapter will be a realization of flip-flop, which was convert one flip-flop to another flip-flop for this process. Okay, so same as we can design counters in a different models, you can use with the flip flops. Okay, so SR, JK, D and F flip flop. Then excitation table. Okay, excitation, we need to know excitation table of the each flip flop. That means input is Qn and Qn plus 1, output is SR. that means if you change the state means what is the input, this is a reverse operation. In characteristics table, we are giving the input, what is the output, like that we discussed. In the excitation table, output like this. So what is the input? That is the excitation table, which is used for realization of flip flop, that is conversion of flip flops in the next chapter. Okay, thank you.